Hi everyone, welcome back to my YouTube channel, and today I'll be doing this differential equation question. As you can see, it's a really complex one. So it's gonna be a pretty long video. So I'll be breaking this video into two parts, part 1 and part 2. And yep, let's get on with it. If you have any doubts, just drop them in the comment section. Okay, then, so what I have here is the answer. Just based on the picture. So I'm gonna solve this and get this. Okay, so given, and they've given us a substitution too. So the second derivative plus tan x into the first derivative plus y cos squared x equals cos squared x e to the power sine x. And the substitution is z equals sine x. So they've given us a substitution because solving this differential equation is really complex. You cannot solve it without a substitution. So they've given us this. So we're going to find the second derivative of z and x. So we're gonna put them as substitutions. So this will be simplified using this substitution. So our first step would be, let's first differentiate this. So d z of dx equals differentiation of sine x is cos x. And can write dz over dy equals to dz dx into dx over d what? Then can find dz over dy equals cos x into dx over dy. Yeah. So you can also write this as dy over dx. I'm just writing, putting dy to the numerator and dx to the denominator. And I'm going to subject this. So dy over dx equals to cos x into dy 2 over dz. So what I did was since everything's multiplication, you can take dy, it's like cross multiplication, right? See, dz over dy equals cos x dx over dy. So I took this there, and yeah, and just cross multiply to dy over dx the other side, dy over dz together. Yeah. I hope you understood. Okay, and then now we found this. Now we have to find the second derivative. So we found a substitution for the first derivative. Now we need to find a substitution for the second derivative. So we'll use that. And so when finding the second derivative, you differentiate this again. Second derivative equals to cos x into the second derivative. When you differentiate this, it's the second derivative. And it's going to be this into dz over dx. So I'll just tell you. So if you look at this, you have y, x, and z, right? 3 different terms. So there's a rule. So when you find a second derivative for something like something like this. So when I differentiate cos x and into dy over dz, it's going to be cos x into the differentiation of dy over dz, right? So when you differentiate dy over dz, it's going to be the second derivative. It's going to be the second derivative into another derivation. I'll tell you how to find it. It's pretty simple. You just look at dz, you look at dx. So you just write the second derivative into dz over dx. That's all you. That's how you have to do it. Just don't like overthink it. Just keep it simple and just do it like this when you have complex questions like that. It's gonna be this over dx. It's gonna be the same for most of these substitution differential equations, because they've given a substitution. They said it's z equals sine x, right? So we don't have y. So if we have y in this substitution, it would be pretty easy. But it's pretty complex because it's just z, an unknown term, and x. So that's why you do it. Plus dy over dz into the differentiation of cos x. That is minus sine x. So this will give you cos x into d, the second derivative, to dz over dx minus sine x dy over dz. Let me just recheck again. Yep. Yep, everything looks good. So instead of dz over dx, we can put this back again, right? And yet you're going to get the second derivative into cos x. This is even cos x, so you can just write, you can straight away write cos squared x to the second derivative of z minus sine x dy over dz. Okay, now you found the substitutions. So you got to use these two. So I'm going to write the whole question again. So we have the second derivative plus tan x to the first derivative plus y cos squared x equals cos squared x e to the power sine x. Yep. Okay, so instead of the second derivative, you can put this section. So you're going to write cos squared x to the second derivative minus sine x dy over dz plus, just write it below, plus tan x into the first derivative, which is cos x dy over dz plus y cos squared x equals to cos squared x e sin x. Just leave it like that. Okay, and that's gonna give you, so I'll just write it again, cos squared x minus sin x plus, and here it's sin x over cos x into cos x, right? Because tan x is sin x over cos x, to dy over dz plus y squared cos squared x equals to cos squared x e to the power sin x. So you can see these two cancel off, and since it's plus, I'm just rechecking it again, alright? So you can see these two cancel off. Those two cancel off, and you end up with cos squared x plus my cos squared x equals to cos squared x e to the power sin x. Cos squared x is common in all three terms. You can cancel that off. Now you end up with sec the second derivative plus y squared equals to e sin x. Okay. And that will give you, where for e to the power sin x, should we had the substitution, z equals sin x, so you can put in t squared, so the second derivative plus y squared equals e to the power z. Oh shit, I think is the question has y cos squared x, but I put a y squared x. I'm sorry about that. So it's just y. It's y cos squared x. Now, because I was thinking, why is it y squared? Because you can't solve that. It just needs to be y. So yeah, this is what you end up with. That was just a silly mistake of mine, because the question says y cos squared x. I just put a y squared instead. Yeah. So now we've got to solve this. And this is pretty easy. So you should know when solving this, so let me write this. If we have a differential equation, this is an example. So if you got something like this, you have to remember that you can write this as a lambda squared plus b lambda plus c equals, this is part 1. The continuation will be in part 2.